Good. Okay. Okay, so is my screen visible?
Yes, sir.
Okay, good. Okay, so let us start. 111. Anyway, a few persons join later, let them. Okay. Okay, so I will switch to full screen mode. So you have seen so far certain features of the C compiler. I mean, mostly restricted to GCC. And you have also seen how to build libraries and similar efforts. Now today, what I will do is I will concentrate on a debugging tool called GDB. And I will show many of the features of this GDB so that you can have, I would say, good debugging possibilities. Okay, so let us start with some motivations. Why? Why should we use debuggers? Of course, this is definitely a very important thing. Writing error-free codes, in particular, which are very large, is every programmer's dream. Error-free means bug-free. Now, what kind of errors can be there? There may be compilation errors. Okay. There may be logical errors, and there may be runtime errors. Okay, compilation error means your program is syntactically not valid, or you have used a variable before declaration, or similar kind of things, or certain functions are not defined internally or externally. So compilation fails. As long as the compilation fails, the debugger cannot do anything about it. You have to write a syntactically correct code and semantically correct code and generate something like error out. After that, debugger comes into picture. Now, logical errors may be because of your misunderstanding about the problem and many other things, or your coding errors. Okay, syntactically and semantically correct, but it is not doing what it is intended to do. Okay. So this logical errors and also runtime errors, you may have division by zero, you may have segmentation faults and all that stuff. So for these two types of errors, the debugger can help you identify what are the bad parts of your code. Okay. And since we have been teaching PDS for so many years, so whenever your code does not run, or I would say it does not produce the intended results, the students keep on thinking that there is a problem with the compiler. I have done everything correct, but still it's not working. So it's a bad compiler. But note that a compiler is usually never faulty. Okay. The problem of encountering segmentation faults or encountering bad output is almost always a problem with your code. Okay. So I would not say a compiler is, I would say, never faulty. That's why it's within quotes. From time to time, there may be exceptional cases where the compiler does something wrong, but these are so, I would say, improbable that it usually never happens. Okay. And I would say this thing never happened in my life, in my programming life, which began something like, I would say, 30, 40 years ago. Okay. So I have faith in the compiler. And if your program does not run or does not give the correct outputs, so question your understanding of the problem and your code. And debuggers can help you to come out of your problems. Okay. So here are some of the features. You can step through your code line by line. Okay. You do not have to write printf statements or something like that after every line. Okay. You can keep a watch on variables. So you see that some variable like sum is not doing the desired thing. So you will say that after every step you print sum for me. Okay. So this kind of thing you can do. And many other things. You have a recursive program or many function calls, nested function calls. Okay. So what is the recursion stack or the call stack at this point of time? So all these things you can do using debuggers. And you now have no need to write diagnostic printfs. Okay. The debugger will do it for you. Okay. And there are many debuggers. We will give you an idea of the GNU debugger called GDB. Any other debugger will work more or less in a similar fashion. And in particular, there are many debuggers based upon this basic debugger. For example, there is something called XXGDB, which is basically built on top of this basic debugger. Okay. And they will make sometimes your debugging problem slightly more, I would say, user-friendly. But anyway, whatever XXGDB does, for example, is exactly what GDB does. It only gives you a graphic interface. That's the only difference. So all the concepts that you are going to see in what follows today remain the same. Okay, only the output is not on your screen. I mean, not on your terminal. Instead, there is some window will open and will guide you to do whatever you can do in your screen. But anyway, so that's concepts we want to introduce to you, and the remaining you can figure out. The graphic debuggers are easier to use, more user friendly. So the concepts are important. Okay. So we make a first example of how to use a debugger. Suppose that you want to compute the area of a triangle whose three vertices or corners are x1, y1, x2, y2, and x3, y3. It will compute the area. So you first make a printf statement. Okay. Then you say enter the coordinates of the first corner and you scan x1, y1. Enter the coordinates of the second corner, scan x2, y2, and similarly x3, y3 is scan. And you possibly remember that this is a formula for the area of a triangle, this plus this plus this. It turns out that this may be negative, okay, depending upon the orientation of the points, clockwise or counterclockwise. If it is less than 0, just make it positive by negating it. And this is not exactly the area. You divide that thing by 2, and then you print the area of the triangle is this. Okay, although this x1, y1, x2, y2, x3, y3 are integers, up to this point, area remains an integer. But as soon as you divide by 2, there is a possibility that it becomes something 0.5. Okay, if you divide an odd number by 2, it may become something 0.5. Therefore, I am taking this area as a double variable. Okay, float will also do, but anyway. Okay, so this is a fairly straightforward and simple-minded code. Now let us see how I can use a debugger to track the progress of your code line by line. Okay, first of all, whenever you want to use the GNU debugger, you must compile your source code with the -G flag. So this is the debug flag. Okay, so henceforth I will not show you this compilation stage. So just say GCC minus W all. Told you that this W all or minus W is always a good thing to include during compilation time. Then you give this minus G. Of course, it may be given before this also. Anyway, then it generates something unless you specify minus O something, some file name, it generates A dot out. Okay, so let us take A dot out. And you simply say gdb dot slash A dot out or whatever initial, I would say, messages like this, simply ignore. These symbols, this minus G flag adds some symbols in A dot out. So if you do not compile this code if you do not compile with this minus G flag, then the symbols will be absent from A dot out, and you can perhaps do very little with your code when you run in tandem with this GDB. Okay. So the first thing is GDB,
Sir?
you give the executable file name. Yes, tell.
Sir, from some time before your voice started breaking, so we could not hear last few
Yes,
lines.
sir.
Oh, is it so? Is it
Yes,
clear
sir.
now?
Yes,
Is
sir,
it
it is now clear.
Okay, so just interrupt me when you cannot see my voice. I think there was some problem in the morning class also. But after
Sir,
some point of time, everything went well, right? Yeah, you just interrupt me
Sir,
when you cannot hear me.
Sir, you better start from gdb.a.out.
From here, okay.
Yes, sir.
Okay. So you compile with this flag minus G. Okay. And then you run A dot out, not itself, but ask GDB to run A dot out. Okay. I will give some initial message, forget that. And then it says that reading symbols from whatever executable name you have provided. If you do not compile with the minus G flag, then the symbols, some symbols will be absent from this A dot out. And at this point of time, if you want to do, I would say, use the debugger, it will be of little help. So you always compile with minus G so that it adds some symbols to the A dot out or your executable, and once you specify this, it reads those symbols and then it is ready. Okay, so it gives you a prompt GDB within parentheses. Maybe in other systems it may be a little different, but so all these things are in my computer, which is Ubuntu. And then it simply waits for you to do something, to give some instructions, to issue some instructions. Okay. Now, if you simply say run, it will start the program and it will proceed as if you have run A.out here itself instead of GDB. Okay. Let us simply print the first statement, first printf. It will say this, wait for you to input two things. You input say 3 and 8, 6 minus 7 minus 1, 5. Eventually it does all this computation and simply reports that the area is 16.5. Okay. And since this is exit 0 case, GDB knows that this process exited normally. Okay. And this is how you get out of the debugger. You say quit. Q for that matter. Okay, so we will look at it later. And once again, shell prompt comes. Yeah, tell.
So do we need to install this GDB separately, or will it come with the compiler when we download it?
I do not know, but you just type GDB. If nothing happens, then you have to install it. If it is already installed, then you can use it. I am not very much sure whether it is bundled. Also, it
It is
depends
not
very much
bundled,
on the
sir.
distribution. If it is not bundled, then you have to install separately. So you know how to install. For
Yes,
example, sudo apt install GDB. Okay. Okay. Yeah. Okay. So after GDB loads a program executable, so this run and quit are two commands, GDB commands that you learn here. Okay. Quit simply exits the debugger, irrespective of wherever you are in your program, and you get back the shell prompt. Okay, $. Anyway, so this is precisely what happened if you ran a.out from the shell prompt itself. So it doesn't help you in any way. So what is important here is that somewhere you have to tell GDB you stop here. Okay. After that point, I want to monitor the progress of my code line by line. Okay. So that requires something called a break command. But then how do you know where to break? So this is what I illustrate in the next slide. So,
excuse me, sir.
Yeah.
Sir, could you please start the recording?
I have not started. I have started.
Yes, sir, it is started.
You said the recording is going on.
It's going on.
Oh, sorry, sir.
Okay. 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 So you have to give some breakpoints. So for that matter, you can use the list command. Okay, that keeps on listing your code 10 lines at a time. So here is a there are several things. You simply say list, or you simply say list m comma n, then it will list line n through line n of your code, or you can simply say line m or list k. Then it will list 10 lines with line k at the center, or maybe the 5th line or 6th line, something like that. So here is an example. So it's that same thing. You simply say list, it will print the first 10 lines. Again say list, it will print the next 10 lines. Then it will say you say list, then it will print the remaining 7 lines. The code is 27 lines long only. If you try to list again list it, then you'd say line number 28 is out of range. It has only 27 lines. But you can definitely say list 15. Then this 15 will appear somewhere in the center. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 10 lines. So this is the 6th one. Okay. Or you can say I want to list line 18 through 22, then it will list you. Okay. Of course, if you have the source code open in some editor, you also note this or get these line numbers. But even if you do not have this source code open in some editor, you can still get the line numbers. Okay. Okay. So now, given that you can see your code, the source code line by line, you can now add a breakpoint. Okay. So that is the important thing. Set a breakpoint, and then you step through your code line by line. So you say break line number. So this is one way of using break. We will see other uses of break, other ways of, I would say, introducing breakpoints. But at the moment, because this is a very simple program, I will just say you stop just at line 11. Okay. But do not execute line 11. Up to line number 10, you do, and then 11, you stop. and I will decide what to do. Okay. Then if you say run, it will go through the first 10 lines and then breakpoint 1 at line number 11, it will stop there. Okay. And it turns out to be this. Okay. Note that whenever GDB displays you a line, it has not yet executed that line. It is just going to execute that line. Okay. And it is waiting for your instruction, what I should do now. And there you can supply many instructions. So do this thing. So the first simple thing is you are happy. OK, so it's going to print this. OK, you simply say next. OK, go ahead. Next means go ahead. Then it will go to the next line. So you can see that printf is not printing anything. That's a different thing. Let us not worry too much about this. This is because of the buffered IO in C. Forget that. Okay. If you had a new line here, it would have printed here itself. Okay, but I have not done it that way. Then it says scanf %d %d. So it goes to line number 12. It has not yet executed that line. It is simply waiting for your instruction. What should I do? Okay. See, once again say next, and then this prompt comes and you supply values for x1 and y1. Okay. Then it goes to line number 13, waits for you. What should I do? You say next, 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 next. Okay. Eventually, it reaches line number 18 where real calculations start. Okay. So it says area equal to this. You say next. Okay, I'm happy. Then it goes to the next line, area increment area by this quantity. And then you think for some reason that everything is running perfectly well. So instead of next, you say continue. Okay, so continue means I will no longer monitor the progress of my code line by line. So you continue. So how long will it continue? There are two things you must understand. If there is another breakpoint, you can have multiple breakpoints. I will tell you why or how. Okay. So it will continue until the next breakpoint, or you can say continue to, then it will, I think it will skip one breakpoint and stop again at the second breakpoint that it encounters. But now you have just a simple linear code, no loops, no function calls, nothing, just a straight line kind of code. Therefore, this continue will essentially stop this line by line displaying and waiting for your instruction. Instead, it will simply continue until the end. And when the compilation succeeds, it says area of the triangle is this, and then you say quit. But I have used Q instead of quit, so I will come to that a little later. Is this clear up to this point?
Sir. Sir, when we use continue, the program directly executes and print output or goes to next breakpoint?
Goes to next breakpoint. Now we have only one breakpoint and there is no loop, so you never come back to that breakpoint.
Okay.
So we will see examples where you come back.
Excuse me, sir.
Yeah, tell.
Sir, like we can see that after the first 11th and the 12th line, the printf line is being executed. So
No, that's what I told you. You will not fully understand why this is happening, because the short and correct answer is that in C, all input output are kind of buffered. Okay. So this is not a very big line. It consists of something like 50 characters. Okay. And the buffer may be 1024 character long, 512 character long. So unless there is a necessity to flush that buffer, it will momentarily store it in the buffer. Okay, the runtime system. Okay. But then this is the thing, scanf this. Okay. Okay, so if instead of colon, if you said just \n, so that also flashes the buffer. If you have done it that way, then it will print it here itself. Whenever you say next, it will print it. Now it is printing later. This is because of buffered IO. This is not a problem of GDB. It's not in the control of GDB. Okay, and I told you, you will not fully understand this buffered IO for the moment.
Sir?
Yeah.
Sir, I am not understanding the concept of breakpoint.
Breakpoint is just to say that you stop here and wait for my instruction. That's it. You say you go to, whenever you go to line number 11, after that, you just wait for my instruction. You print that line and wait for my instruction.
Okay. So, sir, can we predefine the breakpoints just before running the GDB?
No.
I mean,
okay, I think there may be some runtime option. I have never checked it. That is the reason I told you. So you can find your line numbers even without opening any editor. And you see, you think that this is a good breakpoint. Okay. I'll ask GDB to stop there and wait for your instruction.
So,
yeah, tell.
So like, can we do like this? First, I define a breakpoint at say line 11, and then suppose some inputs are taken, and then I like define after break 11, I define let's say break 5 or like a breakpoint at fifth line. So like, is it possible?
Yes, I will come to that little later. You can add breakpoints. Although that example is perhaps not, I would say. You will see. Yeah. Okay, yeah, you can say break 11, and then in the next line you can say break 5.
So, sir, like what happens if suppose in like after break 11, I start with the like that from line 11, and then let's say I have some inputs. I take some inputs in that part, and then somewhere I write continue so that it goes to the next breakpoint, which is breakpoint at line 5. So like what happens to those values that were inputted by the user?
Breakpoints are actually, you may specify them in any order, but they are, I would say, arranged in increasing line numbers. So if you say break 11 and then you say break 5, so GDB will remember that there is a number 1 breakpoint is at 11, number 2 breakpoint is at 5, but it will encounter the number 2 breakpoint first, because that is encountered earlier, right?
Yes, sir. Okay, okay. I understand.
But of course, here also you can say break 5. Okay. Instead of next, you can say break 5. So that will add a new breakpoint, but that will never be reached because it has already passed that breakpoint. So adding that breakpoint makes no sense.
Okay, sir. Yes, sir. Thank you.
Okay. Okay. So again, you run.
Sir?
Yes.
Sir, the GDB command was called with ./a.out, right?
Mm-hmm.
Sir, but the executable should not have any information about the actual source file.
I'll come to that. It's a very relevant question. I will come to that. It's a very, very, very relevant question. Yes. So how does GDB? Yeah, I will come to that. Maybe in the next slide itself. Yeah.
So what is the difference between next and continue?
Continue means do not stop after every line and wait for my instruction. Continue until you reach the next breakpoint or the end of the program, whichever happens earlier.
Okay, okay.
Okay. Yeah. Anyway, that's a very good question. Of course, these printf enter these are not written in the a.out. Okay, so I will come to that question. Okay, so it's in this slide, I believe. First of all, see that writing next every time is not always a very good option. Okay, so GDB gives you some shortcuts. For example, you have seen that I have already used a shortcut called Q. Q is an abbreviation of quit. Okay, so you do not have to type the entire command like list, next, quit, continue. Some abbreviations are allowed, and here is a short list. Okay, and we will come across all these commands in due course of today's lecture. Okay, you can use B for break. Okay, you can use N for next. You can use Q for quit. Okay. Another important thing is that command name abbreviations are allowed if unambiguous. For example, BREA also means break, unless there is some other command like BREA KING, BREAD, something like that. So if bread or breaking are not present, BREA is the unique prefix of a command. That is also acceptable. Okay, but you see that if you have two commands like break and backtrace, we will see backtrace. B is a common prefix of both things. Okay, so but whenever you say B, GDB has the rule that it will mean break. Okay, BT you can use for backtrace, although this is not exactly a prefix of backtrace. Okay, so continue can be written simply as C. Okay, so you will eventually learn these shortcuts as you keep on using this tool. Okay, and in any case, you can write the entire thing without any problem. This is yet another important thing. If you do not write any, I would say, comment, then if you simply hit return, then essentially GDB understand that you are asking it to repeat the last comment. For example, you look at this example here. So you say break 11, fine, run, it stops here. You say next or N or any X, whatever, this kind of stuff. Then instead of writing next, you could simply hit return. It will repeat the last comment. But you have to remember what was your last comment. Okay. Is that clear? Is that clear?
Yes, sir.
Sir, how to hit return?
Hit return, you cannot hit return. Just press enter.
Okay, okay, sir.
Okay. And this is the question which you raised in the last slide. The unaltered source file must be present for GDB to run correctly. The source code must be there in addition to your a.out, which is compiled with -g. But as somebody mentioned, your .a.out does not include your source code lines. GDB reads it from the input file, the C file, and therefore it has to be present. Moreover, it should not be altered after you compile, otherwise these line numbers may be completely jumbled up. This is okay, right? Makes sense.
Sir.
Yeah.
Sir, but how does GDB knows like which a.out is the source file linked to?
Okay. So that is actually written. This part is written. Do you remember anything? So when I use nm, that command nm, name mangler, so it says that this symbol comes from stack.o. These symbols come from q.o. This much it remembers. Do you remember that?
Yes, sir.
Okay. So a.out at least remembers that this is your source file. Okay. So you do not have to do any specific thing. Just compile with the -g flag. Okay. Okay, and also try GDB with multiple files, multiple source files, and see what happens. I will just give you a brief idea how you can run GDB on single source files. Okay. So remember this, we will once again come to it in a later slide. The unaltered source file must be present for GDB to run meaningfully or correctly. Okay. So unaltered is also important. If you change the source file, then your line numbering and everything will be completely jumbled up. Okay. And then if GDB does something wrong, you should not blame it. Okay. Okay. So with this, let us see more features of this debugger. So you can set multiple breakpoints, as I have already mentioned. And you can give a command called info break to list all the breakpoints. And continue stops until the next breakpoint is reached or the program ends, whichever happens earlier. Okay. And other things that you can do with breakpoints, some other things I would say, you can disable a breakpoint for the moment. You can enable a disabled breakpoint. So we will see examples in the next slide. And delete a breakpoint. Okay. Okay. So let us come back to that code. You have loaded that a.out. This is another way of introducing breakpoints. You can say break and a function name. Okay. Then you essentially imply go to that function and then stop. Okay. So essentially it may be line number 5 or whatever, the first real instruction in your main. Oh yeah, it's line number 5. Okay. So break main, breakpoint 1. This is line number 5, and then you say make another breakpoint at 11. So line 11, second breakpoint. Make a third breakpoint at 18. So 18. Fourth breakpoint at 24. So line 24. Of course, here I have inserted the breakpoints in ascending order, but you do not need to. Okay. You can give these things in any order. Break 18 followed by break 24 followed by break main followed by break 11. You can do that. That doesn't matter. Okay.
Sir,
Yeah.
sir, here, if we have user-defined functions, then will that breakpoint stop at prototype, or if we define prototype above main and write the functions after the main function?
No.
Where will it stop?
Prototype is not important. Prototype does not do anything, right?
Yes, sir.
It simply says the input-output behavior. It does not do any computation. So it's not in the prototype. It is in the actual body of the function.
Okay.
Okay, so if you have defined these 4 breakpoints, and if you want to see info break, you will see that breakpoint number 1, number 2, number 3, number 4. They are this line, and also in a.out, these are the addresses. You do not need to worry too much about these addresses. Okay. And it says whether it is enabled or disabled. And you can say disable, the third breakpoint. Okay, note that I have entered it 5, 11, 18, 4, 24 in that order. It need not be. Okay, And then if you say disable 3, and once again, if you want to see the breakpoint, so you will see that this is not enabled. Other 3 are enabled, this is not enabled, that is it's disabled. Okay. So you can once again enable 3, and then if you info break, and you will see all these are enabled. And this is the difference between delete and disable. If you say delete 3 and then you say info break, you see that breakpoint number 3 is completely vanished. Okay, it's no longer there. So that's the difference between disabling and deleting. Any problem? Any questions?
Sir, now if we create a new breakpoint, then it will be given number 5, right?
Maybe I didn't try it. It doesn't matter. Maybe it will be given the number 5, or maybe it will be given number 3. That is GDB's headache. Why do you worry about?
Yes, sir. Okay.
Yeah, I do not. I didn't check it, frankly speaking. Yeah. Okay. Okay. So this is fine. So you can do line by line monitoring of your code. This is the first thing you learned. You can have multiple breakpoints. So continue moves you to the next breakpoint or to the end of the code, whichever happens earlier. Okay. For example, here after line 7, you want to break. You want to continue. You do not want to stop at line 8, 9, and 10. You simply say continue, then second breakpoint will reach, and GDB will once again stop. Okay, and so on. This kind of thing happens. Okay. Now, this is very important thing actually. So you just say break 18. Let's say in that same TA area.c. Okay. So where the actual computation starts after I would say your scanfs. Okay. Then you are going to execute this statement. Okay. So you are just waiting at this point and GDB asks for your instructions. You could have said next so that this is executed and it will stop at the next breakpoint and next instruction, next line. But you want to monitor what are the variables, what are the values these variables store. Okay. Of course, here you have done just a scanf and you are immediately checking what values they are. That's pretty straightforward, but whenever you are in a big computation involving loops, many variables, arrays, blah, 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 you may see that my variable x1 should have the value 1, but for some reason it is having the value 20. Okay, and there may be multiple reasons why this is happening. Okay, so you can check. So you just say print. So this is the next, I would say, thing that you understand. So print x1. It will say $1 equal to 3. Why $1, $2? I will come a little later. In fact, it's written here. Okay, print x2, x3. You can even, I would say, supply expressions for this. x1 plus x2 plus x3. So this is 3 plus 6 minus 1, it prints 8. Or expressions like x1 plus x2 star x3, which is 3 plus 6 times minus 1, which is minus 3. Okay. Or complicated things you can see. The last thing, as soon as you print, there is something called a value history. Okay, the printed values are stored as $1, $2, and so on, and can be accessed using these numbers, $1, $2, $3. For example, I can say $6 by 2. It gives me minus 16. Okay. Why minus 16, not 16.5? Because this is an int variable. This is also an invariable, so this is an int division. And whether or not typecasting is allowed in this context, I am not very much sure. You have to figure out. But definitely, if you say $6 by 2 point or 2.0, then it would print 16.5. Okay. But whether you can typecast this to double, I do not know. I have never done it. Okay. You can figure out by experimenting yourself. So print gives you two things. One, at that point of time, what values are stored in variables, and you can supply expressions also. And the second thing is that these printed values are stored in a value history, which you can refer later using this second number, dollar whatever, 1, 2, 3, 4, 5, or 6. Okay, any confusion?
Sir?
Yeah.
Sir, what would happen if we try to print the uninitialized variable?
Okay, I'll show you. Yes, I will show you. I think it is there in the next slide itself. Okay, there is another thing. This actually does not add to the value history, but instead of print, you can say some other thing called display. Okay, display area. Give a variable name, you say display. Then what happens? After every line, whatever value is stored in area will be printed. You do not have to keep on saying print area, print area, print area, print area, but this variable is associated with this display. Okay. Of course, you may have multiple display variables. They will all be printed. This is only one. Okay. So when it stops at just before doing this, you say display area. Okay. Then, as you mentioned, at this point, this is the first position where I am supplying any meaningful value to area. Until this point, area is undefined. I mean uninitialized, not undefined, uninitialized. So you see some garbage value like this. Okay. Note that, again note that, whenever it is waiting for you to do something, after printing a line, this line is not executed. That is the reason after this line is executed, area gets a meaningful value. But GDB stops. It says that I am going to run this line. What do you want me to do? And you tell display area, it displays something like this garbage value. And then when you say next, you don't have to say display area again because it's already listed. You want to keep track of area. So it says area equal to -36. But once again, note that at this point of time, line number 19 is not executed. This is the value of area after line number 18 and before line number 19. Okay. Yes or no?
Yes, sir.
Okay.
Sir?
Yeah.
Sir, we have specified n. So why debugger is taking this display area as its command?
N is next, yes. The point is that you say it once, it will keep on printing this after every line. And there may be some command to stop this display, which I for the moment do not remember or know. If there is a possibility to stop this display. But if you say display this, it will keep on displaying after every line.
Sir, will this display area not display the area after the end of the program?
Mm-hmm.
So like after the last line.
Yeah, printf is also a line. it is going to execute it. But before doing that, it prints because you want to monitor the variable area after every line. So it displayed it.
Yes, sir. After this, we write continue. Then it is not printing.
Once you say continue, then everything will continue. No longer this will be continuously displayed.
Okay, sir.
Okay. And once again, if you hit another breakpoint, then once again, this area will be kept on being displayed. Okay.
Okay, sir.
Okay, so this is a continuous monitoring of a variable or one or more variables. Here I have illustrated this using only one variable. So instead of printing, you say just make this task of printing easier for me. After every line, I would like to see what value this variable or these variables have. Okay.
Sir, is there any command to run one line at a time? Like keep doing next automatically?
No, what does it mean?
Like, sir, when we write continue, it directly go to the end of the program. But we want to print the value of area at each line without writing next every time.
I do not think so. But as I mentioned, if you print n here, from that point onward, you simply can keep on hitting return or enter. You do not have to write n or next or something like that every time. If you want to, repeat the last command, just hit enter. And the thing that you're asking will not happen. Okay.
Yes, sir.
As far as I know. Okay. And never forget, you say this is minus 33. So if it is less than 0, then area equal to minus area. Okay. But here you see 33. It is not already divided by 2. Because the debugger says I am going to execute this line. I have not yet done it. Supply me some command. Okay. So this area is before the execution of line number 22, not after. Remember this. Okay.
Yes, sir.
Good. So that is display. What next? Yes. You can actually forcibly set variable values. Set values to variables, and which will override the, I would say, whatever values it is supposed to possess. So let's say this is a simple thing. So a equal to 5, b equal to 8, two int variables. And then you say print %d, print maximum of 5, 8 is equal to 8. And once again, you do the same thing. It will print the same thing, right? 8. Yes or no? Now let us see. If you ask GDP to stop here after executing this line. Okay. After executing this line, you set a breakpoint here. Okay. And then if you give some new value to A or B, then these values will be lost. And therefore, the second printf may print something very different because you have set the variables to a different value. So let us see what happens. So you put a breakpoint at line number 5. So let me count. 1, 2, 3, 4, 5. Okay, 5 is just the beginning of main. Oh, okay, fine. So I just said break main. So from the beginning of main, I want to break. Okay. And then if you say next, this is another thing. Possibly this is an error, but this error happens quite often. This program is not being run. You have to say run. Without that, nothing happens. Okay. Okay. So maybe this is an error, but this is just to this also illustrate this thing. You have to run, otherwise nothing happens. You set breakpoints and lot of things, but nothing will happen until you run the program. Okay, so breakpoint this a equal to 5. Okay, so this is line number, sorry. Line number 9, b equal to 8. Then you have this. Then it says max 5,8 is equal to 8. Then it is going to execute the second printf. Okay. Before you allow it to do, you simply say, I want to change the value of the variable b to 2. Okay, so b was what? 8. But now you are giving it the value 2. Just to see what happens. Then you say print b. It will no longer print 8, it will print 2. And then if you allow this comment to, or this line to be executed, it will say max, not max of 5 and 8 is 8. It will instead say max of 5 and 2 is 5. Makes sense?
Sir,
Ah,
sir, we have already executed our source file, right? Then how set where b is equal to 2 will change a dot out?
we are not executed fully, right? We are executing line by line. So GDB stops execution
But
just
the
before
code
line.
is compiled and we have made a dot out, right?
Yeah, that is true. But whenever in your code you refer to some variable, it is not a constant, right? You'll go to some location and read the value there.
Yes,
And
yes.
what by the set var or set variable, what you are doing, you're altering the value, whatever is written in that location.
Okay, sir, understood.
Okay.
Sir, can you please once show the code again?
But I will go. But what is important, I will just go. Let me just, something came to my mind. This is the reason you were told, I think in the last class, not to use any optimization variable, optimization flag during compilation. In this code, whatever is happening, A and B are given some constant values, and if you give some optimization flag, it may no longer, it may happen like that. No longer goes to that location and goes to this second location and fetches these values and does this computation. The optimizer somehow sees that this is just 5, this is just 8. It can simply write max 5, 8 equal to 8. Okay. So if it happens that way, then of course you cannot set. Even if you set the variable b to 2, possibly it will once again print max 5, 8 equal to 8. And that is the reason it is not a good idea to I would say compile with -g and maybe -02, -03, something like that. Avoid any optimization flag to let the program proceed as you intend. Okay, so yeah, tell me, what was the query?
Yes, sir, I got it now, sir.
Okay.
Thank you, sir.
Okay, so that's the reason you never compile with -o flag along with -g. That's not a good idea. Your program might behave in a strange way. Okay, yeah. Okay, so now you have simply seen some straight line kind of programs doing things one by one. What happens if I have conditions and loops? And finally, what happens if I have function calls? It turns out that there is nothing special about loops or conditions. Okay. So when you go to the end of the loop, the execution immediately goes to the top of that loop, and you will keep on seeing the progress of your code line by line. Okay, nothing special needs to be done. Okay, if your program loops in a I would say set of lines, GDB will also say line 10, 11, 12, 10, 11, 12, 10, 11, 12. It will keep on saying like that as long as the loop goes. So there is nothing special. Okay. So maybe I will give you an example. Yeah, tell.
So in case of loop, suppose after running few times, can I remove a breakpoint?
At any point you can remove a breakpoint. You can delete a breakpoint.
So how do we remove a breakpoint?
Okay, the point is that first of all, what that breakpoint is. So if it is somewhere that happened earlier, then whether you delete or not, it doesn't matter. Okay. If it is ever reachable from that current position because you are in a loop or this breakpoint is after the loop, you can disable it, you can delete it. Okay, no problem actually. But if you delete a breakpoint, then that I would say that normal behavior will not immediately appear. You have to say continue. Does that answer your question? I am deleting this breakpoint. Now you continue.
Okay, sir.
Okay. Yeah. So what happens here? So keep on entering non-negative integers, and I will try to find the average of these numbers and enter the negative integer to end. Okay. This is actually what is called a risky program because the first integer may be a negative thing. So then n is 0, sum is 0. Therefore, it's a division by 0 error. So of course you can, I would say, add some additional check. If n is equal to 0, print average does not exist, something like that. So, but for simplicity, let's assume that the user will enter at least one integer. Okay. So now this is a while one loop. You will soon see that even if you put a breakpoint somewhere here, at the beginning of main, it will never print this. It will never stop at this point. Can you tell me why? It will stop here, 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 here. It will not stop at this. The reason is this actually does not generate any code. While one is just go ahead. Actual break thing comes here, and whenever this end of loop exit is encountered, you come here, but you just simply say go ahead. Go ahead means go to the next instruction. So this while one, this line does not generate any code. Okay. But if it involves something like while x is less than y or thing like that, then you would see it will stop here because that involves something, some non-trivial computation. Anyway, so let us see how GDB behaves when you run this code. So break main, run. This is executed. Keep on entering non-negative integers. So print and scan. So next number 5. So you see, keep on entering is fine. So 11 is print next number, you scan. So 11, 12, 13, 11, 12, 13. Okay. 11, 12, 13. Then 11, 12, and you say -1, then it jumps to line number 15 and prints the average. So there is nothing special about loops. Is that clear?
Sir, will the for
why
loop
it is
also
not?
run the same?
Hmm?
Will the for loop run the same?
Always the same. While or for it doesn't matter.
In the for loop, there will be some increments and all, right? So will it show on?
You can anyway say for semicolon 1 semicolon. Then that is equivalent to while 1, right?
Yes.
It depends. If there is some I would say, meaningful computation there, you can see that thing. And if you compile with the minus O2 or minus O1 or 3 flag, you can see certain lines missing or it's not behaving in the usual way. So do not compile with minus O and minus G simultaneously. Okay. So there is not, yeah. Tell.
Sir, in the next page.
Next page. So 11, 12, 13, 11, 12, 13, 11, 12, and once again, once you hit -1, this is executed, jumps to line number 15.
Yeah, okay, sir.
Okay, so in fact, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is never printed. 11, 12, 13, 11, 12, 13. And whenever this, you enter some negative number, so this is 13, 14, 15. It will come here. Okay. Okay, so I think I have talked for more than 1 hour. So let us have a small break. I will come back in 5 minutes. Okay. Okay, I am back. So let us continue the discussion on GDB. What remains is how do you handle function calls? Okay, I will once again go to the presentation mode. Okay, so that's fine about loops. There is nothing special about loops. All the old constructs will continue to work. Now, there is another command you will now learn that is called step. As long as function calls are not involved, next and step basically mean the same. Next means go to the next line and step means step to the next line. The only difference comes when that line for which GDB is waiting for your instruction contains a function call, then this next and step have different behaviors. Otherwise, they are the same. Okay. In all the previous example, I could have, instead of saying next, I could have said step, 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 step. Exactly the same thing will happen. But the difference between next and step is meaningful when there is a function call involved in that line. Okay. In short, next does not go into the function calls, whereas step goes into the function calls. So if you say next, that function will simply be evaluated, and whatever you do with the return value or values, that will come to your line and you will go to the next line. But if you say step at that point of time, then GDB will actually enter that function and once again execute that function line by line. Is the difference clear? I will soon give you an example. But is it conceptually clear? No.
Sir, an example would be.
Yeah, I'll come to an example. Definitely, I will give many examples indeed.
Sir, what if we call one function from another function in the code and there we write next? Then what will happen? Like, let us say the .c file.
So main.c, let's say, calls Fibonacci.c. And suppose that inside that Fibonacci function, not .c, Fibonacci function, you have a breakpoint. Okay, so once you have a breakpoint, after that point onward, it will keep on stepping, even after coming out of that function. Unless you say continue.
Sir, when we are in function, if we say next, will it go? What will happen? Will it come to the main?
Let us see. Okay, so instead of asking this theoretical question, let us see what happens. But this slide is just a brief, I would say, listing of all the comments. If you want to return, or if you want to go out of the function, and without, I would say, stopping that line by line execution, you can use finish or return. These two things have two different meanings. Finish says that you continue normally to the end of the function, print the returned value and add this value to the value history, and then you keep on once again go ahead with the line by line execution. Okay. What return does is something a little bit peculiar. It leaves the function immediately. It does not go to the end. Okay. So I will give you examples of all these constructs. Okay. So you understand the difference between finish and return. Finish is basically continue until the end of the function. And return means leave the function immediately. Okay. And of course, you have seen we have set a breakpoint at main function, but you can do it at any other function. Okay. And as I mentioned earlier, except for function calls, step and next work exactly the same way. Okay, so now examples. So once again, let us look at that tarea.c. Sorry. Only thing is that instead of computing the area in the main function itself, I have written some function tarea, which takes this x1, y1, x2, y2, x3, y3 as variables. It computes inside this function and simply returns. Okay. So this is just to illustrate how step and next are different and some other things. What is the difference between return and finish? These things will be illustrated by this toy code. So remember this code, and I will go to the next slide. Same thing, read this x1, y1, x2, y2, x3, y3, and then instead of embedding this code here itself, I have written the area computation thing in a function called tarea. I'm calling it. Okay, then usual print business and exit 0. Okay, so now I have put a breakpoint at main, then I say run, then program to calculate, it prints and it reads the values 3, 8, 6, minus 7, minus 1, 5. Excuse me, and then it comes to line number 25. And it is saying that I am going to execute this line. What do you want me to do? If you say next, it will not enter the code of this function. Instead, it will complete the processing of this line and go to this next line, which is 26. 27 is exit, goes back. So if you look at whatever, if you want to step inside this function, so area at this point is this, area at this point. If you want to stop at every line here, okay, like here, 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 here. Okay. Instead of specifying next, you should give it the instruction. I want to step into the function. So this is the only place where next and step behave differently. Here you can say step. You will have exactly the same thing. Step, 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 step. But here, if you do not call step, you will not enter the code of this T area. So let us see what if we write step. So once again, we are in this situation. GDB says I am going to execute this line. What should I do? Now you say step. Okay. Then essentially you enter T area. Now you can see there is a problem. I do not know this thing is consistently happening in my machine. So GDB does not give the correct value of x1, y1, x2, y2, x3, y3. Is it a bug or some problem that can be fixed? I still do not know a fix of this. Okay, but when you see near the end, it has given some value, correct values to x1, y1, x2, y2, x3, y3. Okay. So if you know I would say fix of this problem, please let me know. I could not figure out. Here it prints some garbage values like this, and that happens consistently in all runs of GDB that I have made. Anyway, in an ideal situation, it should say x1 equal to 3, y1 equal to 8, x2 equal to 6, y2 equal to minus 7, x3 equal to minus 1, and y3 equal to 5. But it does not do so. Why these things are uninitialized? It is still not very clear. The reason may be this: before this line is executed, x1, y1, x2, y2, x3, y3 do not get the assigning values. It's possibly a reason. Okay, after this is executed, x1 will become 3, y1 will become 8, and so on. But before this line is executed, they have uninitialized values. It may be the reason why this is happening. Okay. So I would suggest that ignore these things. Okay. After this point, if you want to print x1, it will print the correct value 3. If you print y1, it will print the correct value 8, and so on. Okay, but after this line is executed. Okay, so this is not a good thing about the GDB debugger, but it happens like that. Anyway, so let us see. So if you say step, then only we go to the beginning of the function. And once again, you can proceed line by line. So area is this. This line is not yet executed. So if you print it, you will get a garbage value like this. Next. Then you come here. Now, what is the result of x1 times y2 minus y3? That will be stored in area, and that is printed here. Then you say next, next. Okay. And after some point of time, you think that I am done with this function. Okay. Let it now normally end without further stepping. So you simply say finish. So that it run till exit from this. Okay. Then, so it is line 9, 10. Let's see. Let's look at the code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at this point 10, there is still some computation left. So you are asking the function to step, to continue, rather to finish. So this will be executed, and eventually area will be returned. And you once again come to this line. Okay, GDB prints this line and stops for your, waits for your instruction. That may be line number 26 or something, or 25 maybe, 26, yeah. Yeah.
Sir, if after the line area divided by equal to 2, there is a breakpoint at that line, and let's say we see finish, so will it stop at area divided by 2, or will it end the function?
I understand your query. Try it. I never tried it. So if the finish process encounters another breakpoint, what will happen? Nice question. I didn't try it. I didn't try it. Without trying, I cannot give an answer. Okay, so
yes, sir.
If you have some such small doubts, just go ahead and check yourself. Okay. I mean, GDB will not bite you. See what happens. Yeah, interesting questions, but anyway. Okay, and then you say next, eventually it exits. Okay, so this is one thing. And what is that? Oh, this is that finish thing. Now, if instead of finish, you said return, what would happen? Some amount of computation is still left, right? For example, it has to be incremented by this, then possibly negated, if it is already a negative thing, then divide by 2, and then this value will be returned. Also note that the returned value is stored in the value history. So you printed this, so your value history number 1 will be this, number 2 will be this, number 3 will be this. And also the return value is added to the value history. Okay. But if instead of finish, you said return, what will happen? Step, once again step inside this function. So it's normally junk value, then minus 36, minus 18. Then instead of finish, you just say return. It will ask for your confirmation. Do you want to return now itself? If you say no, it will keep on doing this step-by-step thing, continue doing that thing. And if you say yes, okay, this will immediately return. It will not finish the remaining part of the computation. But at that point of time, area has the value minus 18. It will return minus 18. Moreover, nothing is added to your value history. Make area return now, yes. At that point of time, area has the value minus 18. And you are saying return that area. It will return minus 18. So is the difference between return and finish clear now?
Yes, sir.
Yes, sir.
So it says area of the triangle is minus 18. Nonsense, right? This is just because it prematurely returned from the function. And it did so
Sir,
because you
sir,
instructed
if we
it.
write return, if we write return, will the function return the value? Because even that part is skipped.
No, return will return area. This function is supposed to return area.
But we did not reach that line, right? We don't know what to return. So how will the GDB know which value to be returned?
Yeah, so now there is no, actually, if I look at that code, this will return area itself, okay. But if there are multiple return statements, maybe you are returning 1 at some point, 0 at some point, 5 at some point, or some variable thing at some point, which one will be returned? This thing I leave to you to figure out. I didn't actually, I would say, experiment. I didn't experiment with that exact return value. Okay, here actually there is no problem. Area will be returned and there is no ambiguity. Okay, so it will return area, whatever it is at that point. Okay.
Sir, if the function supposed to return x1, but we are at the line like where we are. So which line will it, I mean, which variable will it return, area or x1?
No, here there is a clear instruction that you should return area. So it will return area. And you just check if I say return x1 here, possibly it will return x1. These things you actually, I would say, experiment with. If you just say return
And sir,
x1.
what if we declare the area variable after this statement? Means the area has not been declared yet in the function.
Yeah, I would do these experiments. I have not done it. In fact, return is not a good thing. It's a premature return and therefore it is not really going to do what I would say the correct thing. So possibly that return value, whatever it is not, I would say, meaningful to the rest of your code. Right? It says the area is minus 18, which is nonsense. This is just to illustrate the difference between return and finish. So maybe you will never have an opportunity to use return in your real debugging experience. Okay. Finish is the better thing. So some books do not even talk about return. It's somewhat funny. And the questions that you raise, there are many unanswered questions. I have not experimented with all this, I would say, questions. There is definitely some answer, and the GDB manual may give you a more, or should give you a more comprehensive, I would say, description of the behavior under return. Okay, this is just to make you acquainted with that return and finish are two different things. I would say that in normal execution, you should always have finish, never use return. Then the program is not going to work as intended, right? And the experiments that you talked about, please go ahead and do yourself and see what happens. Okay.
Okay.
Okay. Now, what about a recursive function? So this is one of the stupid functions. We should not write this Fibonacci in this recursive way, although we have taught you to do it this way in your what is that called? In your PDS. Okay. So here I am calling this function. So if I just say next here, it will invoke this and silently execute it and come to this line. But if I say step, it will go to the step function, and suppose that n has a value bigger than 1. So then what will happen? It will stop here, it will stop here. I say next, next, and come here. Now again, you have the option of specifying step or next. If you simply say next, this thing will be, in a sense, invisibly or silently executed. If you say step, it will go to the second invocation of fib. Once that returns, it will once again come to this line. If you once again say step, it will go to the second invocation of fib in this line. And you do not rely on whether this is executed first or this is executed first. Okay, maybe this one or this one. Okay, so let's see. So these are the same function with line numbers. So remember this line number. 16 is where I'm making the call. And 8 is where two recursive invocations are made. So 8 and 16. Now let us run the code. I'm putting a breakpoint at main and equal to, yeah, it's line 16. If you simply say next, it will not step into the function. It will simply come to the next line and print it. F8 equal to 21. Okay. But if I say step after line 16, then it will go to the function. Check, no, this is not true. So go to next line. This is also not true. Go to the next line. So if you want to go again into this recursive function, again you have to say step here. Next will simply silently execute this and return. Is it clear? So let's see what happens if I say step there. So line number 16, step. And once again, you see this n has got a garbage value. So do not rely on this. Okay. Then line number 8, if you say step, it will go to the first invocation, which may be n-2 or n-1, because this value of n is incorrect, you will not get a good idea. But once again, it will come here and ask and wait for you to tell whether you want to make next or step. In fact, this may be, I would say, second recursive. It's not exactly this second thing. This will call Fibonacci n-3, or this will call Fibonacci n-2, and so on. It is that thing. So every time you want to enter a function, you need stepping instead of nexting.
So if we do finish, then also after the return statement, it will ask for stepping or next for the recursive call.
I understand your query. If you say finish, then the current invocation will finish, not on the top of that. That makes sense. Okay.
Okay.
Yeah. Yeah. Again, I didn't explicitly experimented with it, but that seems logical. The current invocation will finish, but the next, the function which called me, control will return there. And once again, the line by line behavior will restart, resume. Okay. Okay, so that is the idea. Every time you want to enter a function, you should enter using step. A single step will not keep on, will not let you stepping again and again. But you can do one thing. You can specify a breakpoint at the function name, but then even if you say next, okay, it will go there. But since there is a breakpoint, then you can make it this way. Next, 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 next. So this also essentially, I would say, instead of writing step, you have put a breakpoint at the beginning of the Fibonacci function. Then next will also step into that because it encounters another breakpoint. So it will keep on stepping through line by line. This is fine. So even if I say next, it will go to the beginning of the function fib because there is a breakpoint there. Or somewhere inside that Fibonacci code. Any question?
Sir, I had a doubt for the step command.
Tell.
Sir, suppose that we have multiple files and we have put step after it encounters a function which is calling the lines of code from some other file. So will it go and
let's see that instead of fib.c, it will say other thing.c. That is fine, but that is one of the questions that I'm going to discuss next. It tells you, right, which file it is in.
Yes, sir.
Okay, it will happily go to that other file and keep on doing that thing there. No problem. The only problem comes when you want to step into a function which is not written by you. That is a problem, right? Otherwise, you can see fib1.c, fib2.c, whatever your file, everything is there. There is no problem. So let us see stepping into an external function which is not written by you. Okay, so I am just running this. And then never forget that printf and scanf are functions. So long as function calls are not involved, the step and next are exactly the same thing. But what now will happen if you want to step into that printf function? There will be two problems. Problem number one is that function may or may not have been compiled with the -g flag. If it is not compiled with the -g flag, possibly you will not get enough information about that function. But what is more important is that recall that the original unaltered source file must be there in the current directory or wherever. Okay. Without that, GDB cannot offer you any help. So in my distribution, printf was defined in some .c file called ioputs.c, ioputs.c. Okay. So the writers of that library, glibc, wrote it in this file, and you do not expect this to be bundled with your distribution. Okay, of course you can bring the sources, provided that the sources are available. But we usually do not do it, right? What shall I do while looking at the source code of printf? Okay, so my machine does not have this source code. So if you want to step into an external function, you will keep on getting. Now we've step here, you can say next or step or whatever. You will keep on getting, I would say, bad results. No such file or directory in something, and then again some message, no such file or directory, low level lock, all these things, these are all needed. Okay. So be careful. Do not enter into or step into external functions. But if you have done it accidentally, what is the way out?
Finish.
Finish, exactly. Okay, so that it will not keep on bugging you with so many error messages. Okay, so you simply say, oh, I accidentally stepped into a function, an external function, just finish it, let it finish. Good. So any questions up to this point? I think there is just one more topic I need to cover. That is the call stack. If there is a doubt, let me know.
Sir, finish also requires the you to go through the entire function. So how will we go through it?
I didn't understand your query.
Sir, when we write finish, you said that the remaining part of the function is executed, then it is returned.
Mm-hmm.
So if inside printf, even if we write finish, shouldn't it still be a problem? Because we don't know where that printf, what is inside printf, right?
No, that I mean executable is there, right? Whatever that .o file or the .a or .so file is, it contains a complete definition of printf.
Okay, sir.
Okay, we'll go to the end of that function, and whatever it is supposed to return, it will return. Printf actually returns something. More often than not, we ignore that return value. So don't worry. Printf actually returns an int. Do you know what that return value is?
No, sir.
It's
The
the
number of arguments.
Number of characters printed. No, number of characters printed.
Okay, sir.
Okay. Anyway, don't worry. Okay, so we'll go to the end of the printf function code. I mean that executable, and resume normal behavior. Good. So anything else?
Sir, all these functionalities, are these also applicable to C++ as well?
Yeah. Instead of GCC, compile is G++.
And so the GDB will remain the same?
GDB will remain the same.
Okay, sir.
There should not be any special thing.
Sir, it's just GDB only for C and C++.
I would not say yes. It may support other languages like GNU Fortran 77, but it is certainly not for Python. If you want to use the debugger for Python, there must be something else. Java or Python, they are not integrated in this GNU framework.
Okay.
Okay. But there may be other languages which GNU supports, like G77 or something like that. Those things will again come under the purview of GDB. Okay, so let us go to the last topic. It's going to be a long session, but anyway. So a function call defines what in this context is called a frame. So here are some comments that work with frame. So it's a kind of recursion stack. So every I would say recursion stack, or I would say call stack. So every entry in that stack is called a frame. So you can simply say frame. So this lists some information about the current frame wherever you are. And if you want a more detailed listing, so you just say info frame. So it's a more detailed information. I will exemplify all these things in a few minutes. And backtrace is print the entire call stack from top to bottom. And you can actually move inside this stack by up and down. But note that this up and down is with respect to the call tree, not with respect to the stack. Essentially, for a stack, top means up and bottom means down, right? That's a natural human convention. But when I say up and down here, I am essentially referring to the call tree rather than the stack. Okay. Okay, so I will give you an example. So, and another thing, up and down does not change the execution to go up or down. So it's not like finish or return. You just go move inside the stack and can see the details of the frames in the stack using info frame or frame. It's just your position, not the position of the code. Okay. So I will illustrate this using a stupid function, stupid program. So for I equal to 0 to 5, less than 5, it calls some function fi. Fi keeps on calling another function g, and after that it will decrement n by 2, and this g in turn, if it is greater than or equal to 3, it calls hn minus 3, and the task of hs is just to print this nonsense thing. I am called with this parameter. Okay. Now, how does the call tree look like? So at the top, main is called, and this will called f for 0, 1, 2, 3, 4. Okay, so this will call f0, f1, f2, f3, f4. And inside f, n is decremented by 2, and as long as it stays greater than or equal to 0, it will call g. And for g, the decrement is by 3, but it's not a loop, only once it is done. Okay. Anyway, so 0, if I decrement by 2, that becomes negative, so there is no further, I would say, calls. F1, G1 also, but here G2 decrement by 2, G0 will be called, here G3, G1, G4, G2, G0. Now these are all smaller than 3, 0, 1, 2, 0, 1, 2, 0. Okay. So they will not invoke H. There are only two cases where invoke H will be invoked. That is this G3 or this G4 and this G4. This will call H0. This will call H1. And printf is also a function. Never, I would say, disregard it as a function. So this will call this. This will call this. And I want to set breakpoint here. So I will say break H. And Whenever it enters H, I will see, for example, if it enters here, the stack will store H at the top, G next bottom element, F next element, men. Okay, so men F, G, H. This is the path in the call tree and also the path from the bottom of the stack to the top of the stack. Agree? So when I say up and down, this is with respect to the tree, not with respect to the top. Understood? Yeah.
So like, let us say we are at edge 0 and we go up 2 times. We reach F3, right?
F3, exactly.
Now if we write the command down, then will it go to G3 or G1? Like in the call tree, only one of the branches will be active at one point in time.
Yes,
right?
yes. G1 does not exist at that point. The stack is men F, G, H from bottom to top.
And sir, the previous stack calls will all means these will be returned to the compiler by the time G3 is called. Like F2 will be returned, right? So F2 will not be existing.
F2 will not be there. Only this thing is there. Men F3, G3, H0.
Okay.
The current execution path. Current path in the tree.
Okay, sir.
And again, if you want to step into printf, that will add another frame to your stack. So this is frame number, latest frame, the previous frame, the previous to previous, previous to previous to previous, and this is previous to previous to previous to previous frame. And you can move up and down this tree. But the program will start executing from this wherever it stopped. It's just your movement inside this tree. Okay, so let us see. Break at H. Okay. So file called stack.c, whatever it is, starting program, breakpoint 1. So now if you backtrace, you see that hn equal to 0. Fortunately, this is correct. I do not simply remember whether this is always correctly printed. Maybe yes. Anyway, so you say backtrace. This will show you the entire stack. At the top, you have called H. This is called by G3. This is called by F3. And this is called in main. Okay, this is called by main. Then you say next. Then you encounter a print statement inside H. And just to illustrate the working of the stack, let me enter this printf function. Although that will generate some error messages like printf.c, no such file or directory. Okay. But now if I say backtrace, it will say printf is the top frame and it is called by H0, it is called by G3, this is called by F3, and this is called by main. And even if I continue, I will stop when the next breakpoint is encountered. So that will happen when H is called a second time. So here I just enter printf and ask it to continue. So it go here, return, 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 come here, come here, come here, come here, here. Once again, a breakpoint is reached here. Agree?
Yes, sir.
Okay, so it will stop once again at H1. Okay. So now the path is main F4, G4, H1. Okay. So once again, let us see. This is what is happening. H1, G4, F4, main. Okay. Now, if I move up, essentially means moving down the stack, I will go to Gn equal to 4. Okay. I am in this, okay, so I am at G. Okay, and at G, I am in this line. And this is some information about G. Then move up, we will come to this F. And this was executed when I was in this loop. Now, if you want to see the info of this frame, so this is the frame corresponding to this invocation of F. Okay, so it will give some information. Whatever you want to see, figure out from this and see. Then up, it will move you to where? Main, right? So in main, and I was in line number 23 while executing this. Then if you once again want to move up, you cannot because you have reached the root of the tree. So initial frame selected, you cannot go up. Then down to means in one step you will go from main to FG. So you have come to G. Okay. And then you say continue, you will continue, and there is no other breakpoint, so it will continue until the end. Okay, you work with this. There are too many things I am telling, but you have to get acquainted with these things, and you can be familiar with these things only by experimenting. Happy?
Sir, if there is a breakpoint within the body of a function, but not in its name, and in the main we write next, while will it go inside the function?
Yes, no, it will go inside the function, but it will not stop until it hits that breakpoint.
Okay, sir.
But if you give a breakpoint with the function name, then it will stop from the beginning.
Means, sir, wherever there is a breakpoint, it will stop there.
Stop. Yes.
Sir, if there is a breakpoint in one of the line in function, it will break only if the function call comes there, right?
Of course. Here you can see there is no breakpoint in main or F or G. So whenever it sees the breakpoint at the beginning of H, it stops. Okay. Run. Yes. It will break only at H n equal to 0. And once again, I am not very much sure. These values and values may be a little bit wrong. Usually this will not be wrong. This may be wrong. So you just check. And if that thing happens, don't, I would say, be too much confused. Okay.
Sir, instead of putting breakpoint at using the name of the function, can we put the breakpoint using the line number? For example, 5 here.
If you break whatever the line 1, 2, 3, 4, 5, 6, break 6, you could have called. No problem.
And it will work only when the function call comes.
Exactly. If it is never called, then this breakpoint is never reached, and therefore, yeah, that's true.
Sir.
And if that breakpoint is inside a conditional thing, it may be avoided, it may be skipped. Yeah, tell.
Sir, when we enter breakpoint at the name of the function, the statement which is shown in the terminal is not yet executed, right? Then how will it print the correct values? Because anyways, until that statement is not executed, the values will not have a copy.
I think that is the reason why this n is not getting the correct value. Yes, I told you, yeah, my hunch is also like that. After this is executed, then n gets the correct value. So it prints before that. That's the reason you are getting some garbage value for n. Yeah, correct.
Yes, sir.
Yeah. Yeah.
Sir, you said that in C++ also we can use GDB, but what happens if we put a breakpoint using name and we did function overloading?
I am not sure what will happen. Yes, you can have different constructors. What will happen? Maybe it will apply to all these constructors. I think so. But you have to experiment with it. I am not very much confident.
Okay.
Okay. So this is the last thing. Recall that same Fibonacci program. Okay. So you breakpoint at this function Fibonacci, and you say just to ignore next 6 crossings of breakpoint and stop at the 7th breakpoint. And at that point, if you want to print this stack, it will be something like this. Equal to 0, 2, 3, 4, 5, 6, 7, 8. Okay, and then continue. 1 second, the breakpoint will be activated when new invocation of Fibonacci comes. So now you see 1, 2, 3, 4, 5, 6, 7, 8. Then men. Okay, actually, this is fine, right? There is nothing so special about Fibonacci calls. Recursive calls. Earlier you said main, F, G, H. Now you'll see with different arguments. There is nothing so special about recursive functions. The behavior is exactly the same. Okay. Yeah, I think that's already a very long exposure to GDB. Whatever I say, you have to work with it. Otherwise, things will not become, I would say, easy for you. You need some practice. So experiment with it. And if you want to learn more, then you get some online help in GDB itself. So you can say help. And you can give help a topic. It will give a short information about what step program until it reaches a different source line. Help set where. This kind of thing you can ask the GDB. So within a few lines, whatever help it can provide, it will do so. And if you want to learn more, then read some book. I will actually, I would say, give a pointer in the course page. Yeah, that's all I wanted to say today. So if you have a query, let me know.
Thank you, sir.
Okay, so it's already 2¼ hour class. So let us stop. Let me first stop my presentation. And what else?
Sir, recording.
Recording I will stop, yes. Unless you have no further questions. Okay, I'll stop.